All right, welcome to our first session of Introduction to Machine Learning. We just went over the course syllabus and the course content. We talked about and went through the submission for assignment 0. If you are still working on that, or if you're watching the stream afterwards and you'd like to walk through that, please reach out to me and I'm happy to walk through that with you. We introduced assignment 1. So we started to look at that. We don't necessarily have all the tools at our disposal to do that yet, but we gave an overview of assignment 1 and looked at the course GitHub and repository and all of the content for the semester and did introductions. So we spent quite a bit of time on all of that. Now we're going to dive into introduction to machine learning, and we're going to start to introduce some concepts. We're going to ask, what is machine learning and why is it important? What are some applications that we can apply machine learning to? How should we think about this technology, and how do we interact with it every day in our lives? And we're going to introduce some really important concepts: supervised learning, unsupervised learning, classification, and regression. And we're going to touch on at the very end the overview of the entire machine learning development process when you go to actually build these models, and how broad that process is, and the part of the process that we're really focusing on for this class. At the very end, I have some notebooks to go through some Python basics. We're going to do some reminders on Python basics, data structures, functions, and really gearing towards our focus for this class is we're going to leverage a lot of the Pandas library, the Pandas and other libraries as well. But this is the one that we're going to focus on for assignment 1. Okay, so we went through course overview, we did introductions, course syllabus, GitHub Learning, Colab, and let's dive into machine learning. Actually, I'm going to change my view here. One moment. Okay. What do you guys see here? Do you see? Yeah, that's what I want you to see. All right. Introduction to machine learning. What exactly is machine learning? We know that we're in this course. What is it? And what can it do? What can we actually do with machine learning? Machine learning is the field of study that gives computers the ability to learn from data without explicitly being programmed. This is the definition that I prefer, that I like the best, because it emphasizes 2 very important things. One is the learning from data. So when we build these models, machine learning models, AI models, they are just learning from the data that we give them. And if that data is wrong, if that data is incorrect, if that data is biased, or it doesn't represent the world that we want to build, these machines are not so intelligent that they can infer what they should be doing. They're just learning from what we tell them in the data. So for example, if in the past, we're trying to make a data that makes loan decisions. We work for a bank and we're deciding whether or not we want to approve or deny loans. If we build a model just based off of our historical data, perhaps unintentionally, our historical data represents bias. We only loaned to people who looked a certain way or who did a certain thing in the past. Maybe if we use all of our history and we go back in time, women weren't as common in the workplace as they are today. So our model learns that if you're a man, I should have a higher probability of giving you a loan than if you are a woman. And that is not how we want the model to behave. So it's really important. One thing I want you guys to take away from this course is that our models learn from the data that we give them. And sometimes we have to apply some scrutiny to that data to make sure that is representative of what we want the models to do. The other piece that this definition emphasizes is explicitly programmed. So give computers the ability to learn from data without being explicitly programmed. So if we have a very complicated scenario, if we have a very complicated situation, the models are capable of creating rules in a large set of rules, if else statements, that it would take us maybe in an infinity, a very long time to do. So they can design, they can understand it and kind of map out patterns for tailored to outcomes without us coding every single pattern. If you guys are going to work with the Titanic data set and you have some information about a person and whether or not they survived the Titanic. It's a very fun data set. You've got some data about someone who was actually on the Titanic, and you're trying to create a model to predict, did they survive or did they not? Would they survive the Titanic crash or not? And instead of creating a bunch of rules, if person is like this and this and this, then they survived. Or if they are like this and this and this, they didn't. Instead of us writing those out by hand, which would take a lot of time to discover and a lot of time to find, we can use machine learning to probabilistically create the rules that populate probabilities that would occur. Okay, so in the evolving world that we're in today, you may hear a lot of different terms. You may hear artificial intelligence and machine learning and deep learning, and now large language models and small language models. And how do all of these things fit together? What are the similarities and what are the differences? There are a lot of different opinions on what those things are. Generally speaking, I like this definition. It's evolving and changing, but artificial intelligence is a big umbrella that pretty much includes a lot of machine learning, deep learning, large language models. It's really the definition for it is that a program that can sense, reason, act, and adapt. And a artificial intelligence program that can do all of those things probably brings a lot of different tools to bear in order to accomplish that. So it's not one machine learning model or one deep learning model. It probably has a lot of models as part of a complex system in order to be artificial intelligence, kind of to be a program that senses, reasons, and adapts. What we're focused on in this class is machine learning. And we're focused on very much the traditional side, what I would term as the traditional side or the foundational side of machine learning, which is how do we take a model that uses math and probability and algorithms to map an outcome to a target variable and to create a probabilistic prediction based on historical data. We will not focus on reinforcement learning, and I'll describe that in just a minute, 3 slides. Deep learning is a subset of machine learning, a subset of artificial intelligence focused on neural networks, multi-layered neural networks, and having those neural networks learn from vast amounts of data. And what's really great about this class is we're going to build all of the tools that you guys need in order to lean into that deep learning space. So the algorithms that I chose for this course, the linear regression actually leads into logistic regression. And I personally found it eye-opening how logistic regression is the foundations for deep learning. So by the end of this course, we'll touch on deep learning, and you guys will have a very good conceptual understanding for what is a node within a neural network and what information is passed to that, what an activation function is, and how that's transforming, and how a linear regression relates to and is kind of foundational to a neural network. So very excited about that. One important question to ask when we're building machine learning models or these systems is, what are we going to do with it? What are we going to do with this information? So one very common question that's asked in a lot of industries is, can you predict customer churn? Can you predict, given this customer, if they're going to cancel their subscription in the next 30 days? Can you cancel if they're going to terminate their service with us in the next 30 days? A customer churn model. And given enough data, we almost certainly can be performant at that. However, what are they going to do with that information? If we predict that somebody is going to leave the company, what is the intervention? What is the treatment, test and control treatment that we're going to apply to customers to try to not get them to leave? So important question to ask is, as you're building these models, is if I had a perfect model and it could do that, it could tell the future today, what would we do with that information? How would it serve us? And there are three different things that you can do with that information. It can be, you can create models that are descriptive, that tell us what happened, explain what already happened in the past. So we can have descriptive models that tell us, why did these people leave our company? Can we group and cluster people together so I can look back historically at people and see which types of customers are similar to each other? I want to understand my customer profile. That's descriptive. We can also get into the predictive realm. And predictive is when we want to use data to predict what will happen in the future. In 30 days, 30 days hasn't occurred yet, but what will happen? Will they leave in 30 days or will they not leave in 30 days? That's a predictive system. Prescriptive is recommending an action to take or a treatment to employ. You can imagine a customer churn model that says, I predict this person will leave in the next 30 days. I predict this customer will churn. And I believe that you should apply this treatment to the customer. What I've seen be very effective to other customers to retain them is to apply this type of treatment, offer them this discount, or put this pop-up onto their window on their application that they're using, or send them this nice email. Or so there are different treatments. That would be a prescriptive model. So these are the three different actions or outcomes that we can have from machine learning models. A couple of, let's try to map some of these concepts of machine learning to actual use cases. I think a useful way for trying to understand something is to see ways in which we interact with machine learning in our everyday lives. We've talked about CV in agriculture. We talked about that a little bit, actually using drones to count cows, or somebody had the great example of machinery and equipment that as it is moving along at the very high speed that it does in agriculture, it's actually detecting weeds and targeting, spraying them to remove them, which is very impressive. If you have any social media platforms, what you see on your feed is really driven by ranking algorithms. Your friend recommendations are recommendation engines that are recommending people that you should be friends with. If you work in the finance industry, there's a lot of models that try to predict whether or not we should approve someone for XYZ. Perhaps it is a home loan, perhaps it is a car loan. Based on, so there's a lot of implementations in the finance industry. Of course, we hear about in the claims in the news and the social media about different insurance industries and medical industries and the claims that they are processing and the AI technology that they use to do that. And predicting illness is another very common one. I think you guys will work with the diabetes data set, which is, can we predict health outcomes based on attributes about a person? In the medical industry, we have a lot of data. We have your heart rate, we have your blood pressure. We have a lot of metrics that we collect. Can we use those metrics to predict health outcomes so that we can better treat patients, so that we can provide better care at the right point in time. Self-driving cars, of course, have a lot of cameras on them that allow them to sense and detect objects and rules of the road, structures within the road so that they can follow the rules of the road. So there's a lot of AI within there. Through some of our examples, we'll talk a lot about emails, targeted emails, detecting if it's spam or not spam. In the fashion industry, there is a very famous data set that's a fashion data set that came kind of after the MNIST data set that has different pictures of clothing items. And the objective is to classify these clothing items, classify this shirt, classify this as a skirt, classify this image as jeans. So that might be another data set that we look at. Does anybody else have an example of machine learning or AI that they've interacted with in the everyday world that they'd like to share?
It's not really for in a professional setting, but for Dungeons and Dragons in our D&D group. Every now and then we run across a part of our schedule where we can't really fit something big in there, so we just do what we call a one-shot, a quick adventure. And lately, like sometimes it's almost scary how good it can be when you just give something like ChatGPT a couple sentences to just define a quick story, and then it comes back with several maybe 3 or 4 pages worth about world building and a setting and a problem to solve and the evil guy that you're going after, and you really only gave it 2 or 3 sentences, and just how it extrapolates the information from that and comes up with its own sources and like information to feed into it to just give you a quick condensed story to work with.
It's pretty impressive. It's pretty impressive. At some point, I want to collect all of your experiences with large language models, OpenAI, ChatGPT, that technology that you've been working with. What have you seen and experienced, and what are the quirky things that you've seen it do, and then maybe what are the things that you've seen that surprised you? I'll add that to a topic discussion. It won't be our next one, but it'll be maybe we'll do that on Monday. Do you all use ChatGPT, OpenAI? You all played with it? Yeah.
That's how I got my degree.
I highly recommend that you do use it for this course. I think it is a great aid in programming, and I think it's a great aid in, I think it can make us more efficient as people. It does make mistakes, and I have noticed that quite a bit, and I've noticed from a coding perspective that it tends to jump to the most complicated solution for what you are trying to do. So maybe have a critical eye as you're doing that, and do use it. But also the value in this course will be coming from you being able to understand this and scrutinize the code at the end of the day. Okay, here's our first nomenclature introduction course content that will be on your exam: unsupervised learning and supervised learning. So there's actually more than 3 domains, but for now we're going to think about 3 domains of machine learning: unsupervised learning, supervised learning, and reinforcement learning. In this course, we will not talk about reinforcement learning. We're just going to focus on the first 2 branches here. We're going to focus on unsupervised learning and supervised learning. Supervised learning is when we have labeled data. We have houses. If you guys ever used Zillow, so Zillow has a Zestimate on it. It's like an estimate for what they think the house price is going to sell for. That's a machine learning model. We can predict house prices based on information. So can we predict the price of a house based on the square footage, the number of bedrooms in that house, the number of bathrooms in that house, the size of the lot, etc.? Can we use that information when I say number of bedrooms, size of the house, square footage, those are features. They're, in an Excel sheet, they might look like variables. Those are features. So can we predict the price of a house based on these features? So supervised learning learns from labeled data. At the end of the day, when a house sells, we know if we were correct or incorrect. The house either sold for the price that we said it did or it didn't. It was either $10 more, $10 less, etc. Those are labels. Labels is the outcome that happens when we're trying to predict house prices. We know if we were right or if we were wrong. Unsupervised learning is when we don't have labeled data. So perhaps your stakeholder comes to you and says, I would like you to cluster customers together. I want you to create groups of customers and based on purchasing behavior, and then tell me something interesting about them. Tell me that people who are in cluster 1 behave and interact a certain way. Maybe they're the young and up and coming kids, and then maybe people who are in cluster 2 are established middle-aged individuals raising children, and maybe cluster 3 is so create clusters of customers, but there are no labels. There is nothing saying that this customer should be in cluster 1 or should be in cluster 2. You have to discover and you have to define those clusters yourself. So these are the two situations we're going to focus on when we have labeled data and when we don't have labeled data, or learning from unlabeled data. Reinforcement learning is essentially learning through trial and error. And I actually really love reinforcement learning because I think it represents how we learn as humans. We try things out and you either get burned and you decide, I'm not going to do that again, or you get a reward and you decide, well, I'm going to do that again because that was a good reward. So there are rewards and there are penalties. And over time, the model learns based on rewards and penalties. It's a very different paradigm, though. So we're going to start with supervised and unsupervised learning, and then maybe move into reinforcement learning. So here's maybe a different concept map to kind of map all these things to in the realm that is machine learning. You can imagine we have supervised learning, we have unsupervised learning, and we have reinforcement learning. Under supervised learning, here's our next piece of nomenclature here. We have classification and regression. So under this, here's the two realms we're going to focus on. We're going to focus on supervised and unsupervised. We have classification and regression. Classification is when we have categorized outcomes. It's either 1 or 0, or the outcome is A or B or C. It's apples, or we have a picture, and is it an apple, or is it a banana, or is it a pear? And it has to be one of these categories. So classification is predicting what class or what category it is. In regression, it's focused on a scalar number. So when we look at house prices, the house price can be 0, it can be $1, it can be $20, it can be $2 million. So, and it can be any value in between that, right? It can be $1.99. So regression is focused on a numerical output, and that numerical output can be on a scale of values, and any value in between is valid. So there are different algorithms for these two different methods. In classification, we are going to look at decision trees, and we're going to look at random forest, and we're going to look at k-nearest neighbors. This is a broad class. Like I said, you're going to get a lot of tools in your tool belt here. And then in the next course, we dive deep into the into evaluation. In regression, we're going to look at linear regression. And we can maybe touch a little bit on decision tree regression, but really for regression, we mostly focus on linear regression. When we look at unsupervised learning, we have no labels. We're going to look at some clustering methods, and we're going to look at mainly k-means clustering method. And in addition to this, we're going to look at neural networks, which can be regression or classification. Okay, I think this is my last slide here, and then maybe we'll pick up on Python basics at the beginning of next time. I think we'll have plenty of time. So I want you guys to be able to map what we're learning in this class to the process and flow that you go through in the development of this in the real world. When you're at work, you may have a problem presented to you, and the first thing that you need to do is go through data collection. In this course, most of the time I will just hand you a data set, or I'll point to a data set online, and we're not necessarily going through the time investment of data collection. This is a really large part of the project. In addition to that, it covered in your earlier covered earlier in your business analyst class would be exploratory data analysis. After you collected the data and you had a good structure for the data supporting the problem that you're working on, I would expect you to go through exploratory data analysis, trying to understand what is the data, create some findings, and have a good grounding and understanding of the information that you're working with and how you're going to feed it into your model. Maybe your data is inefficient or insufficient, and there's pieces that you need to shore up. You might have to do some data annotation. You might have to actually have an expert in whatever you're trying to predict label some data for you in order for you to train a model. So the data annotation phase is huge. In my experience, a substantial amount of time for project efforts has been spent on data annotation in order to create a really high quality model. What we are focused on in this course and in the next course is this section here. So I just want to highlight, we're doing one part of the machine learning life cycle that you need to do to actually build a model. So we're going to focus on model training, that's this course, and evaluation, that's the next course. Following these two courses, there is actually an API course that will cover model deployment and model monitoring as well. So you guys are getting that content as well, in the course following this one, in the course following these two. One other thing I want you to keep in mind is that once you build this model, we don't just set and forget it. At some point, your model is going to need to be updated. The world changes, the state of the world changes, data changes over time. The way our world looks today is not the same way it looked 100 years ago. And that change happens at a micro level as well. So there's probably some care and feeding that a model would need after you put it into production and implement it. All right, I just wanted to give you guys that context of where we're going to be focusing, and it's primarily going to be on the model training and evaluation. I have some Python basic slides, but given we have 10 minutes, I don't want to rush through these. I will share the slides with you. I'll share the notebooks with you guys. Feel free to look at these, but we will pick this up in the next recording, which will actually be this Saturday. I'm going to stop sharing here. And I'm going to pause the recording and ask you guys if you have any questions.
After listening to all that, I'm starting to